Welcome back to Aerospace Engineering. Today we're going to work on manipulating our data for airfoil test. So if you are a remote student, you will find your wind tunnel test data right here under windtunneldata.zip. That's on the resources tab of the activity. If you're an in-person student, well then you've got all these data files already. So let's get started. What I've done here, here's my zip file. If I go ahead and click on extract all and set that up for my desktop, I will then get a wind tunnel test folder. In this wind tunnel test folder, or wind tunnel test data folder, what I have is a series of pictures. Those are the PNG extensions. This is a picture of the actual wind tunnel test. In this instance, it is 5 degrees. And I've got two curves. I've got a lift and a drag curve. I'll also find these .jet files, and they vary from 0, or from minus 20 degrees to plus 25 degrees. So what I want to do here is I want to go ahead and open these in Excel. Now I happen to be using Excel 2007. Yours may be newer. So what I do is open my Excel file and then go File, Open, navigate to my desktop in this instance, and open up that folder for the wind tunnel data. And I'm going to start out at minus 25 AOA, but you're going to notice when you first open the folder that it's blank. And that's because you have all Excel files selected. So what I want to do is click on this drop down, choose all files, and I'm going to navigate down to this min20 underscore AOA.jet. That's minus 20 degrees AOA. And I'm going to go ahead and open that. Now it doesn't recognize the file type, but this is a comma delimited file. So delimited is the default. Click Next. Deselect tab and choose comma. And you can click Finish. Now what this shows is basically some data about my test right up here. And then I've got my wind speed, lift, and drag. And we're going to put a third column here, lift over drag. So I want to use my data from down here. And I want to be as close to 50 miles an hour as I can for this particular experiment. So I'm going to go ahead and make this screen, this data file, about half. I'm going to start a new file. So I'll go File, New, Blank Workbook, Create. Let's slide this over so you can see it side by side. Now this is going to be my actual data file. And what I want to do is create 3 columns. The first column is going to be angle of attack, and I'll abbreviate that AOA. Second column is going to be lift, and that's in pounds. Third column, drag, again in pounds. Fourth column will be computed as lift divided by drag. Now I'm going to start this at minus 25 AOA, and then minus 20, minus 15. I'm sorry, I think I started at minus 20. Minus 15, minus 10, minus 5, 0, 5, 10. Now what I can do if I want to autofill this is I can go ahead and autofill. I went up to 25 degrees AOA. So you should have that AOA tab or column. Now to get my data, right here is my minus 20, and I'm going to use 50 mile an hour data, or as close as I can get. So I'm going to go ahead and copy those 2 cells, come over to this, and I want to paste those same values. Now lift divided by drag is going to be a formula. That's going to be equal to, click on the cell with my lift term in it, and you'll see it highlights as B2, slash for divided, click on the cell with my drag data in. That's C2. So that's my first one. So let's open up and continue this for minus 15. And minus 10. And you'll see how I can keep this open and not have to tab between different fields. Now we'll flash forward and I'll do the rest of these in just a second through the magic of the internet. So we're back. I've got all my data loaded, and what you're going to notice is I've got a negative lift as I've got a negative angle of attack, which we would anticipate. And then we started with positive lift numbers. You'll also notice the lift grows as I get a higher angle of attack. Again, we would expect that. We also get more drag as I go to a higher angle of attack. Again, not unexpected. So this lift over drag equation, I can either type the formula in equal, click on the lift cell, divided by the drag cell, or I can highlight one cell of this, then click in the lower right-hand corner, the little square, and pull that down and it'll copy the formula. Either way, go ahead and get that done. So what you'll notice over here is I've got some lift over drag terms, and it's interesting. The lift over drag represents the relative efficiency of the wing, or how much of the wing's energy is creating positive forces that we can use, lift versus losses, which is drag. And you'll see my highest ratio here, somewhere between, it looks to be it's between 10 and 15 would be my guess. It may actually peak between 5 and 10. I can't really tell because we only went at 5-degree increments. So now we're going to make a plot of this. Now, if I arranged my data in this format, it's really easy to make a plot. So I'm going to highlight all my data. And now I'll go insert. Again, yours may look different, but I want a scatter plot, and I want a scatter plot with lines. So I'm going to go ahead and select that scatter plot with lines, and I get this graph. Now, this isn't a bad graph. It looks pretty good. But I'm going to tell you that it's a little bit noisy. So I've got my L over D here, and you'll see that these numbers are way out of proportion compared to my lift and my drag. So what I'm going to do is click on this series right here. And on this series, I want to basically go ahead and add or format my data series. And I want to add this so that it has a secondary axis right here. So click on secondary axis. Now what I've got is a much better representation. I want to add a few other things down here. So a few things that I want to add is I want to add a title to the chart. And in this version of Excel, what I would do is add my chart titles. Now these are insert chart elements in Excel 2016 and beyond. So I'm going to go ahead and add a chart title. And I'll put it right over the top. I'm going to add axis titles, primary horizontal. I want a primary vertical, and we'll rotate that. And now I want a secondary vertical rotated over on that side. So I'm going to pull this out a little bit, and now I can add some information down here. Now what we have down here on the bottom axis is this is my angle of attack. On the left-hand side, swing right over here, I've got my lift, drag, and then the units it's in, pounds. And on the right-hand side, I've got lift over drag. And that's obviously dimensionless. I can expand my chart out, and you're going to want to use this. Now this, again, shows us where that peak happens. Now this is a smooth curve, so all I know is that I'm hitting my peak at about 10 AOA. Peak could have occurred somewhere earlier in here, but we're just going to say it's about 10 degrees AOA, and that's where my wing is most efficient. So it's creating the most lift as a ratio of lift over drag. Now my most physical lift is obviously at the highest angle of attack. That is derived, that most lift there is derived from mostly deflection of the wing at that angle of attack. Now this chart title is my lift drag. versus AOA. And I'm going to put in here 50 miles per hour. That's it. That's all there is to making your chart. You may use a different version of Excel or a different version of a spreadsheet. The process will be the same. Thanks for watching.